Hello and welcome to DevOps Stage 2022. My name is Volodymyr Shynkar and today we'll be talking about Helm. I hope you will enjoy it and let's proceed. So today's topic is writing Helm charts as professional, and we will talk about the inheritance and the best practices. A little bit about myself. I'm CEO at Apricot. Before that, I was working as a DevOps engineer with 7 years of commercial experience. Overall, I have 9 years of engineering experience. I had the chance to work with more than 20 projects with different domains, such as gambling, automotive, fintech, e-commerce, and others. So I hope that my experience will help you to become better. So we have 4 topics, subtopics or something like that. And first we will see how Helm works, the benefits and how to work with it. Later we will proceed to functions and templates. In the third subtopic, I will show you the loops and inheritance, of course, conditions, etc. And in the end, we will see how to deploy it and how to use in production and how to integrate it with other tools. So the first topic is lifecycle benefits and usage. So the benefits, first, it's a packaging, of course. As you may know, CI/CD part ends with packaging. It's an artifact, and of course, Helm can be treated also as an artifact because in result, it's kind of archive which consists from YAML files that has specific application configurations such as values file with all inputs and the templates that needed for application to work correctly. The next one is Helm, of course, well customized application, which you can modify in every stage, such as deployment or building when you build your Helm chart. And I always compare Helm with Terraform because it also supports changes. It also supports constructions such as functions where you can change or modify something on the go. And we will be also doing that with you today. And the third one is CI/CD, of course, and pipelines to the next level, which means with using Helm, you will be able to release better. You, of course, will be having possibility to roll back. You will be having the history and, of course, diffs between each one. And, of course, Helm will help you not just install the application. It will also maintain the source, for example, your repository, and the destination, your cluster. For example, if you modify something or remove some resource, it will automatically remove at the end, for example, in the cluster, right? Of course, Helm is popular, and we already have lots of community packages that help you to basically start from the beginning. You can install whatever you want, any application such as Redis or Elasticsearch. I don't know why you need it, but anyway, it also supported. Any database, any operator, everything is available, ready to use, and can be installed with a few clicks. And of course, it also supports multiple environments. I will show you how to do that and how to, with several strings of code, you can override something and support multiple environments. Of course, that's not everything. It's not the end. We have more. And of course, it can be reused. You can create a template and then just import it, replace with your inputs like image or other configurations such as port or command, and be good to go. You can reuse this Helm chart whatever how many times, maybe 10, or how many applications you have. This time you can reuse it. And of course, the next one, it's versionable. Since we are using Git almost everywhere, and that's not the exception that we'll be using Git with a Helm. Of course, it's versionable. You can roll back your changes, as well as you can roll back the releases. As I mentioned that in the beginning, once you make a release with your application, and then you make another release and another, and Helm keeps the releases on the cluster, and you can easily list it and choose which you want to roll back, or just see the difference between releases. And the last one, but not least, you will see the other benefits in the end of this video. It's you can get rid from using kubectl apply, because it's not the best practice to use that in your CI/CD and to deploy any packages, because usually it's stateless and you don't know what exactly was changed, what exactly was deployed, and you don't know whether it was successful or not. Helm keeps the status of release, whether it was successful or not, by collecting the results of deployment. And here you can see some installation of Redis. In this example, we are adding an external repository with Redis. Then we install a specific version. Do not forget that you need to update your repositories before using it. And as you can see here, we have Redis with version 2 because I already tried to install it twice, which means we have second revision and we can switch between those revisions. On this example, you can see the Helm structure. This is basically default structure. If you run this command, helm create, and then the name of your application that you expect to create, you will see this folder structure. And let's pass through each file. Chart YAML is responsible for, of course, name of your application and version, and some default values like maintainers, and the app version, of course, and dependencies. We will see that later. License, it's basically who created and what you can do with it. Usually we don't use it. README-MD, it's, of course, README. If you would like to share something with your users, you can include usage, some explanations, something like that. Requirements, usually also not used. We will be using charts YAML as a dependence for dependencies, but requirements will not be used. Values.yaml, it's important file. It's also optional if you don't want to overwrite anything, but usually you do want, right? That's why we will be focusing on the values YAML a little bit more on the next slides. And charts YAML, it's also optional. This folder keeps the dependencies. You can just place the dependency inside this folder and it will be also automatically installed. It could be whether archives or unarchived folders with another charts. And the important folder, it's templates. Templates keeps the YAML files, basically the Kubernetes manifests, with your configurations that you wanted to have for your application. We will also see a little bit more examples later. And templates nodes, it's something that you might see if you install your application through the console. You will see the release nodes or the usage nodes. It will be printed as a README file, a small README file after you install your application. All right, here is the chart YAML file. As you can see here, we have an API version. It's version 2. Usually everyone is using version 3, but anyway, you can also use version 2, but it's not recommended. It's better to use version 3. The name of the Helm chart, the description, the type, usually the application, version, and app version. Version, it's a version of Helm chart, and the app version, it's the version for your application. For example, your application has version 2.0, and the Helm was recently created and has version 0.1.0. They sometimes can be different. But anyway, usually people focus on the version, and that would be sufficient. The dependencies. The dependencies, it's something that you want to have along with your application, whether it's a database or some caching server, or for example, some operator that needs to be installed along with your application. Let's say it could be ingress controller or some auto scaling tool, such as CADA or something like that. And you want to have a specific version of that application. You can specify that here, and it will be installed along with your application. Another example, it's a MongoDB, and you can see here another options like alias and of course condition. Those are used for the chart names that has long name, or for example, you would like to shorten it, and instead of using, later on I will show why, instead of using MongoDB, instead of referencing to MongoDB, you will be using Mongo, and the conditioning prevent from installing it if you don't want to overload your application, or for example, for production, we don't need to use Mongo because we are going to use some separated MongoDB server, whether it's Elastic cache for Redis or DocumentDB for Mongo. Then we don't need it in production, something like that. Usually, packages are installed from Artifactory Hub. Before it was developed through the GitHub repository, but later on they deprecated that GitHub repository and created Artifactory Hub. And I think I can show you that. This one. This is how Artifactory Hub looks like. This is the MongoDB, and you can just easily install the application by clicking install, and you will see the examples how to install that, and also the Helm command that you need to run inside just your terminal. Make sure that you have context chosen for development if you would like to test it. Also, you can check the templates, default values. This default value is also a good one. You can see the arguments that you can specify here and overwrite it while using your dependency file, and I will show you later. Let's continue. All right, I already told you about the Artifactory Hub, and this is how repository looks like. It's also a Helm, not Helm, it's also a YAML structure, and it looks just like that. For example, for a metrics server, as you can see here, we have entries, metrics server, the version, and some metadata. It's like API version, app version, keywords, name, and the URL for the archive. As you can see, it's an archive, and of course, it's a package, as we described it previously. You might want to create your own Helm repository, and you can use several options for that. One of those, and most popular for public repositories, you can use GitHub Pages, and it's really easy to do that because it exposes your repository as a web server. You don't need to serve it, you don't need to worry about that, you don't need to launch any service for that. It's just easy to go. And for that, you would need to create a custom branch if you don't want to mess up with updates in your main branch with some notifications or some other files. You can use a separated branch. It is recommended, and of course, if you will be using it, the GitHub Actions will make a commit into that branch, and your GitHub pages will just pick the updates from that branch. Alternatively, you can create some S3 bucket and push the changes from your releases to S3 bucket, and you can host your repository on CloudFront. Oh, as you can see here, you can also use S3 bucket, but if you want to have your repository available only internally, you don't want to expose your charts basically globally, you can use a pod inside of your Kubernetes cluster that makes a proxy, S3 proxy, it's called like that, and then it serves through the Nginx your S3 bucket inside of your Kubernetes cluster. And of course, alternatively, you can use any other web server because, as you can see here, it's basically index.yaml file that needs to be available through HTTP protocol. Now, we will be reviewing the values file. As you can see, we have different things here, and all of them here are the same except one guy, and that guy, it's global. Global has something in common with other charts, right? And it's reserved. You cannot mount something another for that. I mean, you can use global, but anyway, it has inheritance, which we'll discuss later on the third section. This is how values file looks like. Usually you should have image described, ports, service not always, but also preferable, and some enablements, conditions, other things that you would like to customize in your application. Multiple environments, of course. As you can see here, we have a global and we have an environment prod. Usually this will be used somewhere if you're focusing on environment. That's just an example, because on previous slide, as you can see here, we have an environment dev something. Here we have a prod. And as you can see from the name, we are using values-prod.yaml. And let's try to implement that. I have a small project here, not this one, this guy, and we have a values, right? We can multiply these values. Let's call it, as we have an example, values prod, right? We have everything the same here. And we can remove all. We can just leave a tag. Let's say we would like to use older version of Nginx, and this is it. For that, to test it out, I would like to run some testing command, which we will also be describing later. Helm template. We can put some name, test, and then dot. Oh, I'm in a wrong folder. Charts, press demo. All right, we have some result. Let's see the deployment. Nginx, image is Nginx 1.14.2. Let's provide a different values file. as you can see here, now we are using these values. How we can use it? Once we install our application into the environment, or for example, we are using different branches or different CI steps for our application, we can just specify this one argument instead of providing multiple set commands as we have here on the second thing, like override via console arguments. Another example for that, we can use a set argument, and we can overwrite whatever everything that we want, but only from values file. For example, we would like to change a container port. Then we just specify it and provide a different port. And as you can see here, oh, of course. Oh, yeah, we have here. Yeah, as you can see, we changed this port. We can also change image tag equals prod, nginx prod. This is it. It's that easy. And of course, you can have different values file for different branch, but that's not the best practice, because we will be often promoting our Helm charts through different clusters, applications, etc. And it's always better to keep this configuration somewhere during the build or deploy, or maybe not build, but deploy, or on the cluster side. With that, we'll be always sure that we deploying with the correct configuration files, and it will be hard to break something. Yeah, and finally we came to the testings. One of the testings you already seen, it's a Helm template, second one. We also have different other commands like Helm linked. And as you can see, we have some found. Its icon is recommended, but that's okay. Usually that's okay. No one cares about that, but we do have it. Helm verify. It seems like test. No such file or directory. It's because path. Yeah, that's correct. Unfortunately, Helm verify can be used only with the archived repositories, archived Helm charts. It verifies if it's correct, if it's executable, if it's correctly packed, and this is it. And we have another tests, unit tests, verifies, and one of those, it's if you create your Helm chart like this, Helm create test. Let's do it on the charts folder. Helm create test. You will see that we have a templates folder with a test folder inside that templates, and here you can see some kind of test. And what exactly it's doing? It's basically executes something against your application. So, for example, you deployed your application, and you would like to see if your application working correctly. It's kind of integration tests, right? And it is doing some wget command, executing wget command against your application and port. And by this hook, it returns the information back to your Helm, and with that, Helm understands whether your application passes the integration tests or not. This is also a useful thing. And the unit tests, of course, they exist, There are several tools. Unit tests, as you can see on this screenshot, it's an example of unit tests. It's easier. It's also YAML formatted, but it's limited. An alternative, it's a Terra test. It uses a Helm SDK, which supports a Go language. So you would need to develop your unit tests using a Go, just Golang, and it's quite hard and not always needed. But for example, if you are using public repository and you provide this Helm chart to another guys, or for example, you develop this as a template, like general template, and you're using it for multiple applications, and you want to be sure that every functionality works as expected, and for example, you added some functionality, you introduced new CRD, and you need to be sure that previous CRDs, for example, alternatives that you have in your Helm chart, also works. With that, you can use unit test that will specify which CRD to use and test if it still works or not. That's a useful, but used very rarely. So just for information. And the next one, of course, as I mentioned before, if you are developing your Helm chart as a template for your multiple applications or just for development outside, you can do a releases with your application. You can use different CI tools for that, but the main thing is that you need to create a package and keep the changes and just remember which version of your application you just released, version of your Helm chart. And as you can see, you have a points like continuous development improvement. You always will be adding something for your Helm chart because your application grow, and along with that, your Helm chart also will be growing. For example, you decided to add readiness and liveness props, continuous development and improvement. You added a commit into your pull request or commits message. Those commit message should go to the change log. You develop different environments. You need to remember names of those. You need to maintain the different values files. Also a point. And the last one, you are providing a Helm to third parties. You also need to keep track of the changes and post some changes which you developed within this version. The next one is finally functions and templates. And basically we have plenty of them. And the first one, it's built-in objects. By default, Helm has different variables. For example, the chart name, the chart version, the release name, app version, service, etc. It's basically everything that you have here in chart YAML file. Let's open something smaller. And as you can see, we have a chart name, we have versions, and you saw something like release name. Release name, it's the name that you gave the application once you deploy a Helm chart. For example, Helm install, then you provide the name, for example, backend. Then you provide a path to your Helm chart. It could have some name. As you can see here, we have an Nginx, but the release name will be this one. The path will be ingress demo. And of course, I would like to add a dry run. My Kubernetes cluster is pretty slow, so oh, something is wrong. unknown field labels. I think I did something with those labels. It was here. And this labels. Let's remove it. Pum, pum, pum. All right. And as you can see, we have config map, which has release name in the name. Let's see what we get. Backend config map. And as you can see here, here's the name. And we can reuse it as a variable. And as you can see, we have some default values. For example, if you haven't provide or leave an empty values file, you can just leave a quotes. And if you do not override it elsewhere in different environments or through the set arguments, it will use a default value variable from here. There are another thing that you can use with built-in variables. There are plenty of them, different types. As you can see here, we have release that I just showed you. We have chart arguments, not arguments, attributes. We can also manipulate something with files. We have capabilities and templates. Each of them has different things, but most popular will be these two. But I will also show you some template example. As you can see here, we have a config map.yaml, and probably you have a deployment file, and the config map often uses as some configuration file or just config file for your application, right? Where you keep some changes or something like that. And if you update the config map, the deployment will not be triggered. And if you want deployment to be triggered, you need to change something inside of your deployment to trigger the rollout inside of your cluster. For that, we can use a checksum based on the config map and include it to the annotation. So the checksum will always be different than previous file, right? Because you change it, so checksum will be different. This will trigger your deployment to basically recreate the pods and reread the config map with your new changes. As you can see here, here's a little example of mapping the values to your templates. Basically, it has a scope. Each YAML file has a scope, and we will be able to change the scope or refer to the scope or modify the scope, and everything we will discuss here. So as you can see here, we have image and repository, which equals to nginx. So in our templates, we should refer to values.image.repository exactly in this structure. And this is it. That's really easy. And yeah, we should use it. The next one, it's custom variables. We have one here, for example, this labels. Oh, that's not this one. Oh no, this one. We have created a custom variable. It could be anything else. For example, these guys. It's often used when you need to keep something shorter or do some modifications later with array or with this file, because as you can see here, we have to use another function always somewhere here, and it sometimes overcomplicate things. So you just define it to a shorter name, and later on in your template, you can just use a name, and this is it. And it will be really short. And you always know that this one refers to include something, something, blah, blah, or in example here, it will print out everything from here to basically include to these templates. Why it's not templating? Helm template. Ingress demo. Oh, it works. So as you can see, these labels were included from this guy basically to here. And if you have several config maps or you have some repeated structure, you can just include it several times and it will works. The next one, it's a global variables. We already saw those variables, but let's discuss it a little bit deeply. So the global variables used when you need to reuse it in subcharts, or for example, you need to manage also scope several times. But basically, I had a situation when I was creating some resources which were in a subchart, in a child chart, and I was needed to provide some list of those resources that was created within the subchart. And in order to do that, I need to pass it first to a subchart, then somehow return it to my global, to my parent chart. And for that, I was using global variables, and then I specified the list of resources in a global, and it automatically passes to a subchart and also automatically passes to my parent chart. We also have a different way for doing that, but that's not the best practice. I will show you that later. And of course, we have named templates. The benefits from using this named templates is that it also available through all of your charts. Basically, it's also available to a subchart. But there are one thing that it's also available through all your files. For example, through all these files, and that exactly used for labels and for example for names. As you can see here, we have created this test guy, and if you check this helpers tpl file, you will see that we have defined the test.name, which has the structure to make sure we are comply to the Kubernetes resource naming. And basically this dash means that we are cutting something. We make sure that we have name not longer than 63 characters. And we also provide the possibility to overwrite the name if needed. And basically whatever you want, you can define here. So that's basically a default structure of this template. And one more thing, that if you are using a file with underscore under the beginning, it will not be included, it will not be rendered itself. It means that it's already a template that should be reused somewhere along your application. As you can see, it's automatically created a deployment with include test full name from these templates. Basically, this one. It's automatically created, and they are providing you here in examples. Basically, that's an example of some template, and as you can see, it's not easy, and sometimes it gets very complicated. So yeah. And finally, something that we already seen but haven't used yet. Functions. There are a lot of them, and you will be using those quite often, basically everywhere. On this screenshot, you can see an example of those. For example, repeat, quote, upper, replace, lower, indent, and also we have an ident. And we have an example of those. We have, where we have it, in a config map. Let's see, we have here a lower and replace. Let's see what we have in the values file. We have a favorite, which has some map. It's like fuel, petrol, color, it has underscores, it has different cases. And if we run Helm template, let's see what we have in result. If we check this file, config map, you will see that we are using two different ways of including these guys. First, it's just include exactly as it is. By the way, Helm provides you to include just like blocks from a values file. You can include whole scope, or you can use a range, or basically a loop. We'll discuss it in a few slides later. And as you can see here, we have lower and replace underscores to just a space. And basically in this loop, as you can see the result, basically we removed underscore, we make everything lowercase, and compared to this one, it's saved the structure as it was in the beginning. Use the functions. Okay. And yeah. And finally, we come to my favorite things. It's loops and inheritance, of course, the conditions. Let's see what we have there. And yeah, most exciting part. So Helm does support conditions. It also have or, else, if, and etc. It has different types of loops. It's also similar to Terraform. And let's see an examples. Right? As I mentioned, this is basically the simplest if condition here. You can see here in the top, if ingress enabled, then it will be created. Otherwise, it will not be created. The same here for another example. For example, if you need change some CRDs, depends on which technology you would like to use, or you would like to do something different. You can specify, for example, if rollout enabled, then use this API and the name of kind. Otherwise, use regular deployment. The same during some configuration of volumes for your pod. You can also specify if condition here, persistent volume claim. If it's specified in values file, it's not defined, it's not commented or something like that. You don't need to specify, like you can see here, enabled. It's also true if the scope has anything defined inside of this variable. If you provide an empty variable, for example, it should be defined, because if condition checks it. If it's equals to false or empty, it means also false. So it will be working if you provide just an empty volume. Right? And finally, loops. We have two types of loops inside the Helm chart, and they are called width and range. Width used rarely. I don't know why, but it's basically, it has only one purpose, it's change the scope. The scope, it's basically the scope. Oh, I need values. It's basically this is the second scope, a fuel. But I will show you another values file where we have more scopes. For example, here, as you can see in examples, we have several scopes here. I mean, one, and we can loop through these three guys. For example, we check in whether it's just regular variables. If it's parameter store, we need to use a different exceptions for that, and as well for the secret manager. Another example of scope, it's services, and we just range through each of them, and then we are, while ranging, while doing some loop, we are working inside of the scope. Those other guys will not be available, and we will be referencing to this ingress or resource limits directly, like dot resources or something like that. I will show you an example. Remember, we are ranging through the services. We change the scope to the services. And the referencing here, and we're again changing the scope with annotations. And these annotations inside of the ingress, of course, because that's another scope, because we are in ingress. We are arranging services, and then we are doing a second range. Ingress are array or something, because this one default list ingress or list configs. So it's complicated template. But anyway, we are changing scope when we are using loop. Here is the small range, and as you can see, we're doing this through the hosts. So basically, we changed the scope several times. And where is the hosts? Hosts are here. We are doing range through services. Then we are entering inside of the scope. We are doing range through ingress, and then we're doing several third range through hosts, and then we are working with these guys. So that's why we need to focus on this scope, which we're changing, and then work within that. If we need to reach some of these variables, for example, service account or readiness probes, they are common for all the containers and for all the resources. Let's say we have several ingress or we have several deployments. And for that, we are using $sign before a variable. For example, where we have an examples. We don't have an examples here, but I think we have an examples. Not here. And also not here. I'll be showing then in ingress. Oh, there you go. So if you would like to reach some upper scope or the root scope, it's called root scope if you're using this $sign, then you can reach any other scope within the values file. There are another way you can define something inside of your range. For example, if you need to reach something within the second range, because remember we have three ranges. We have one range here, second range here, and third range here. If we need to reach something within the second range, within this one, we can create a variable. I don't have an example here. We can create a variable within the second range, and then it will be available, this variable, like this one, it will be available within all the ranges, right? And you can get some information from that. Why we need that? As you can see here, we have some, let's say, hosts, but still we need to get some information, for example, from annotations. We need to add an annotations, which is not available within this range. And also it will be hard to understand in which iteration you are right now, because remember, we are looping through the items. And to be sure that we will be getting information specifically for this item, because sometimes we can have multiple items. You can see how many of those we have. And then we can also use this variables to get a specific scope. Right, finally. Here is the examples. I already described those. So once you use some range, you're changing scope as well as with width. All right, and I already described this one by $sign. Here is some examples. As you can see here, we are ranging to favorites, and then we are using this $sign to make sure that we are reaching a root scope. As well, we are using another range inside of this one, but the main root scope as well, it's not available, the root scope. And we can just add a $sign, then we will be able to get this pizza toppings. Inheritance. We have several of those. I already described several. And at the beginning, I was telling you that we can use aliases for your dependencies. And here how it works. We can specify value that has a name exactly as your dependency name or your alias name. Then you can overwrite some of those values file, but it should be scoped within the name of the dependency. Also, you can see here we have condition mongo.enabled, and it will be referenced to this one. So if we have true, it will be created. False, it will not be created. And check this one, architecture replica set, right? We have this default values, and let's see what we have for architecture. It's in the main scope, and architecture we have standalone. We would like to overwrite and install it as replica set. Then we just need to provide it like this one, replica set, and just with changing this one in values file, you don't need to provide a whole values file separated for this dependency. Also, we can pass the label, the variables from child charts to parent. As you can see, we can use the from argument, then specify the name of the subchart from where we would like to pass it. Basically from where we would like to grab it. So this is how it works. And it's like another workaround for global. If you don't want to provide and manage the global variables, you can use this the cross-chart variables. So the global also will be a good example if you would like to pass something to your dependencies, or for example, if you would like to specify some or like name override or environment or something like that, it will work. Finally, we have the last one, and we will be talking about managing your Helm chart as application, right? Since Helm really popular in like CI/CD or something like that, and it also has some embedded features from GitHub Actions, like a GitHub action called Helm Chart Releaser that easily integrates to your Helm chart basically, and not Helm chart, to your repository, and you can within the few lines of code inside of your GitHub action create this releaser, and once you merge something into your branch, for example master branch or main branch, it's now popular, this automatically be triggered and new version will be created of your Helm chart, and then you can reuse it somewhere where you can pull this repository. And of course the usage, both ways are okay for you, just to decide which way you would like to use. You can develop your Helm chart separately from the application repository, yes, or repository, and then just include it through the repository. With that, you can keep one Helm chart for your company and then just reuse it always when you need it and develop the features special for your company, because you know that you have pretty common deployment, you have pretty common practices, and you can always manage the versions. For example, production will be deployed with version 1 and development is with version 1.5, for example, right? And you know, if you introduce something, new changes, which are not yet on the production, for example, some new CRDs that you are planning to release, and you can easily promote your application, your Helm charts within the environments, within the application, etc. The other approach, which is here, you can keep your opposite. It's here. Another way, it's you keep the Helm repository along with your application and just run Helm, install Helm upgrade directly from your code, from your CI, and this is it. You don't need to release it. You don't need to worry about repository. It's easier if you have only one application. You don't need to worry about those things. But when you have 20 or 50 applications, it's really pain in the ass to keep all the versions of your applications up to date, versions of your Helm templates up to date, and usually it will be really hard to maintain that. And of course, with using a templated some repository for your environments, it's easy to promote your Helm chart. You can just change in the version, you can reuse it, you can do whatever you want. You just change an image tag and change the version of your Helm chart, and this is it. Helm, it's as another application. You develop it, you upgrade it, and you version it. So it's your application. Another integrations. I think you already have heard about GitOps, and that's one of another applications, or I would say operators or approaches that help you to install and manage your Helm charts. Also, it brings more security to your cluster, because otherwise, if you're planning to install your application using kubectl or Helm install or Helm upgrade, you have to provide an access to your Kubernetes cluster, right? With GitOps, Argo CD, or Flux CD, you don't need to provide that, because there are a different approach, which is called a pool approach. the operator lives inside of your Kubernetes cluster. And in order to do something, you need to install the kind application, which will be referenced to your repository, path inside of your repository to the Helm chart, and some overrides or variables specifically for this environment. And this is it. Argo will or Flux will do the magic for you. I think I will show you some examples and you will see how it works. I have already installed an Argo. It also has a pretty nice UI, and it's good opportunity for you to manage all the applications from UI. You don't need to learn the kubectl, you don't need to learn anything else, and Argo installs really in a few commands. Here is just an example, I specially kept for you. It's a random password that creates during the installation. So this is regular commands. You just need to add a repository, update it, and then you need to install Argo. The description will be printed to you here in the chat. Basically, after the installation, here is the manual how to reach this Argo. Then you just grab the password and port forward, since you don't use, I don't use ingress for this Argo, but you can use ingress, and you will be you can reach the application from user-friendly endpoint with HTTPS, etc. But we don't have it yet. Let's create the same Mongo, right? Which we have here. For that, we need to grab repository name. We can call it Mongo. Project name default. Project name is something different. Let's not deep dive into that. Sync policy. It's a one of the benefits from using Argo and Flux, that it controls and automatically keeps the state of your application. For example, something or someone has changed your manifests inside of the Kubernetes. For example, someone modified your deployment, Argo will automatically roll it back in a second, which is kind of good. It also has self-heal and prune resources. Let's click all of them. Also, we would like to create a namespace. The repository URL will be, which we copied. It should be not Git. We would like to use a Helm. The cool thing that it will grab this repository and will give us the whole list of the available packages from that repository. Let's find it. As you can see here, we have a lot of them. We would like to install MongoDB with a version. Let's install latest cluster, default one, and Mongo. We would like to install into the Mongo namespace. We also have whole values. We can use several values files if those are available inside of this chart, but it's not, it's only one. And we can overwrite something right away from the UI. Then just click create. This is it. Your application will be created in Kubernetes cluster, and you have a nice UI for managing your workloads, and it's reproducible because you can create one Helm chart with Argo CD applications, which you would like to deploy into the cluster, and with one application, it will automatically deploy whole workloads, whether it's ingress controllers or some metric server, etc., Prometheus monitoring, or your applications. Many of them will be installed just with a few clicks. And to create new environment, for example, you would like to create a new Kubernetes cluster, you also need to just install one application with Argo, and this is it. And it's totally reproducible. You can create as many environments as you want, and everything will be reproducible. Also, you can see here, we have a nice view of the resources that was created by Helm, basically controlled by Argo. And you can check the logs, you can check the status and events, the summary, what we have here. Everything is here. Logs. Loads a little bit longer, but anyway, logs will be available there. You can remove, you can modify, you can delete, you can turn off the auto sync, which will gives you possibility to modify these resources right here. You don't need to, again, you don't need to go to the console and modify something. You will be able to do that from UI. You don't need to even provide an access to your colleagues or developers to Kubernetes cluster directly. You can deploy this application, give them possibility to deploy specific repositories or to specific namespaces, and they will manage the Kubernetes from UI. This is it, which is kind of cool. It's already was small demo, so thanks everyone, and I hope you enjoy that. So see you later. Thanks everyone. Bye.